In this particular exercise, we are going to see how to solve a system of three differential equations, ordinary differential equations. Basically, we have dx by dt equals minus sigma x plus sigma y, and this is the second one, and this is the third equation, and the constant values have been provided here, and these are the initial conditions. X of 0, that means the value of x at time t is equals to 0 is minus 8, y at time t equals 0 is 8, z at t is equals to 0 is 27, and the domain is this much, is a variation of time, right? So we are supposed to solve this particular set of differential equations using MATLAB. Right now I'm using MATLAB 2013A, and we're going to use the method of writing it using ordinary differential equations on the solver, which is the numerical solver ode23, right? So basically, before we make use of ode23, we need to write a function definition, or the definition of our differential equation should be contained inside a function file. All right, so what do you have? First I make a function. Okay, function, how I write the output is momentarily, let it be like this. Okay, the definition of the the differential equation definition is like this. In my case, let me write it as 0 1 for the first differential equation, or the okay, first example. Okay, DE, and I'm going to use certain variables, and okay, so I'm going to use these notations IV and I and everything. For IV, I and IV solution, and everything is going to represent for independent variables, and you're going to have dv and d, oops, and you also have dv solve for dependent variables. All right, this way we are not going to get confused, and anyway, we are going to have two inputs for this. One is the independent variable and the other one is dependent variables, and the output is this particular equation. Right, we are going to write the equation as an array of 3 rows. First row containing the first equation, second row contains the second equation, and third row contains the third equation. All right, first equation is basically minus before that we need to define our constants. We have sigma. I'm going to use zig. Okay, sigma is equals to of 10, and beta will be is equals to 8 by 3, and you also have rho to be equals to 28, if I am right. It may be okay, this are all seems to be right. And what else do we need to do? We need to define our dependent variables. X is something, y is something, and z is something, right? What are these somethings? So first we need to look at dx. Only independent variable in our equation is time. All right, so what are the dependent variables? X, y, and z. All right, so all that is being captured in capital D. So capital D of 1 is the first dependent variable, capital D of 2 is the second dependent variable, capital D of 3 is the third dependent variable. All right, so basically now it becomes very easy to write these particular differential equations. On the right hand side, I'm going to write only what is there on the right hand side. Right, so what is there on the left hand side? How do I write it? We will see it later. Right, so now basically what do we have? Minus sigma minus zig into what do we have? X plus what do we have? We also have zig into y. That is our first equation, followed by we have rho into x minus y minus x into z, and we also have minus minus beta into z plus x into y. This is our 3 equations. Let me just cross verify once again. Sigma into x plus sigma into y, that is correct. Rho x minus y minus xz, rho x minus y minus xz, that is correct. Minus beta z plus xy minus zeta z plus xy, all seems to be right. All right, so now What is there on the right hand side? Right hand side, we basically have the derivative of the dependent variable with respect to independent variable, in which case all the three put together, it is the derivative of three dependent variables with respect to one independent variable. So I'm going to capture everything in one symbol. Derivative of the derivative of the dependent variables with respect to the independent variables. Right, this is my definition of this, and this has to be the output. Right, so now we have defined the inputs and the d. That has been done now, and after this has been done, we are just we have finished defining our differential equation. I go ahead and save this particular thing, make sure the file name is the same as the function name, and now we can go to our particular server, de def script file. Right, script file, this is our script file. This script file is going to make use of def. Right, further on we have how do we make use of this particular thing? First we need to define certain things. What is the domain? Right, domain is 0 to 10. Right, domain is 0 to 10, that is right. And what is your initial condition? Initial condition, we have three initial conditions: IC1, IC2 and IC3. all right, IC3, correct. Now IC1 is basically minus 8, IC2 is 8, and IC3 is 27. all right, so now what is your initial conditions? Now initial conditions is basically IC will be is equals to IC1 and IC2 and IC3. Oops, seems to be a problem. Okay, IC1, IC2 and IC3. That is, we have finished writing our initial conditions. Now all we are left out is go ahead and solve it. Now we have seen that this particular I'm going to make use of IVSOL and DVSOL. Right, IVSOL and DVSOL. How do I particularly make use of that? Okay, so now what do we have here? We have IVSOL solution, IV solution, and dependent variable solution. Right, which is basically, you're going to shortly see what these are. Since we have three differential equations, but how many independent variables we have? Only one. So this is going to be only one vector between 0 and 10, and dv solution is going to be three vectors, one for x, one for y, and one for z. all right, so now it's going to be like IVSOL versus the first value of DVSOL, IVSOL versus the z value of DVSOL. IVSOL first value is going to be IVSOL versus x of DVSOL, IVSOL versus y value inside DVSOL, IVSOL versus z value inside DVSOL. That is going to be our result, and we are going to call our solver ode23, and my differential equation is contained in de def. Right, this is the function file. This is the function file. Better to copy and paste it to remove errors of writing, typing errors and everything. And then we also have to define our domain. We have defined our domain and initial conditions, and that is done here. And we're going to put a semicolon and enter. Let's see, let's evaluate this particular. Right click, evaluate selection, and go to this. We have a problem. Okay, undefined function or variable sigma. So we need to go into this solve sigma. I have used sigma here. I'm going to use zig now. Okay, and right click, evaluate selection, and let's see whether it has, oh yes, it has evaluated it. And we are further going to see the solutions of individual variables, three dependent variables with respect to the independent variable. First write the independent variable IV solution versus something. All right, we solve versus something. So we have dv solution of all the rows with first column. Okay, that is one solution, second solution is dead, and this is for 3. Right, so basically this is for time, this is for x, and this is for y, and this is for z. Right, so now we have finished this. Let's specify certain basic characters, like what is the color that I need. I need the color black color, and I need red color, and I need blue color, and etc. And I think we are good to go, and we need to also write hold on in between somewhere over there, and that's it. And we are going to also put legend entry, first legend entry, second legend entry, third legend entry. First legend entry is going to be basically t along the x-axis, and x along the y-axis, and t along the x-axis, and y along the y-axis, and t along the z-axis, and t along the x-axis, and z along the y-axis. I'm going to plot this particular thing. Let's see what is going to happen. We have a solution, and we seem to have the variations like this. These are the variations of our results, and we have in fact obtained the solution for the differential equation, and probably yeah, I'm happy about it. Please comment anything if you need it, any questions or anything. If I can answer, I'll definitely do it. Thank you very much.